Beautiful design was the critical success factor for Reflectly. Reflectly is a journaling app that we created to counteract the stress that comes with social media and technology. Digital well-being is important now more than ever, so our goal for this app is to provide a safe space and break from the stress that technology can bring. Therefore, this app must be personalized, safe, and beautiful, so all users can open up and feel they have a unique relationship with Reflectly.
The beginnings of Reflectly surely was very humble. We were a very small team and only 2 engineers. However, we wanted to reach users on both iOS and Android. So we built the first version of Reflectly using a traditional cross-platform framework. But given that Reflectly is all about beautiful design and user experience, we felt restricted in our ability to deliver a consistent personalized design for both platforms. For example, frequently shadows were cut off and animation were always sluggish. And so it became clear to us that we needed to find a new solution. And luckily we found Flutter.
And it just worked. So out of the box, we got an extreme amount of value that we can then use, and we knew we had to use in Reflectly. And that was kind of a key deciding moment. And from the first line of Flutter code was written, we were done in only 2.5 months. That included some large new features, like our entire premium subscription implementation. Flutter paints every pixel on the screen directly. So now we don't have to worry anymore about differences between how iOS and Android render our content. It still adapts to the unique characteristics of each platform. We can keep a common code base and still build iOS and Android-specific UI where it's appropriate. It was a revelation for us that we're actually able to move so fast while still not compromising on our visions.
So Flutter is great because it gives you control of every single pixel on the screen, but it also allows you to actually structure your code in a way that's maintainable and refactorable. For example, to create the elegant and informative new view transitions, we use the hero widget. And because we're able to nest basic widgets across the Flutter, our initial build of the UI was quick and effective while still maintaining a great performance.
So we deployed the app to millions of users all around the world, and they loved it.
After we launched Reflectly 2.0, one thing that made us particularly happy was how well the design was received. We thought it was beautiful, but it was great to hear that from our users as well.
Overall, we're very satisfied with how Flutter is performing. It has enabled us to build the beautiful UI that we envisioned, which got us featured in Apple's new apps we love. It has cut our development time in half, and we can release new features simultaneously on Android and iOS.
And now, with Flutter for the web, we can deploy our existing code base for Android, iOS, and the web.
With Flutter, we're able to deliver this beautiful experience to millions of users. And month over month, we're seeing double-digit growth.
腾讯旗下的产品团队为数众多，但都有一个共同的目标：为每一位用户打造美丽的、流畅的、与他人相连的体验。无论用户是在使用什么设备，也无论用户是在学习、旅行，还是在分享精彩、享受生活，亦或是在事业上全身心投入。
做英语君完全是从零开始，教育类的产品功能复杂，但是我们只有3个月的开发时间，5位开发者。其实想要完成 iOS、安卓2个端上，从 Phone 到 Pad 各种尺寸上的适配，真的是非常困难。
闹直播的安卓和 iOS 实现差异比较大，我们迫切需要一个能覆盖移动端、外部以及更多场景的大前端方案。
企业辅导之前使用的跨平台框架运行起来效率不太理想，占用的内存也很多。
翻译君有自己的迭代速度，我们需要有新的开发框架，但节奏最好能自己把握。
起点的既有产品服务于商业用户，我们想引入更好的框架，但它不能太影响已有的应用。
叮当的设计迭代很多，但以前就需要我们的开发实现2次。
好在 Flutter 的学习曲线并不陡跳，上手还是挺容易的。我们现在觉得让产品转而使用 Flutter 加 Dart 完全可行。
在使用 Flutter 之后，我们有90%以上的代码是跨平台的。在需求和设计变化之后，跨平台的代码只需要修改1次，2个平台都可以使用。
我们100%使用 Flutter 开发的英语君，就因为精良的用户体验和视觉效果，获得 App Store 编辑的连续推荐。
屏幕适配能力真的很强，从 iPhone SE 到 iPad， 还有各种尺寸的 Android 的平板，这些都没有问题。而且我们还用了不少矢量和动画资源，包括 SVG、图标字体和 Flare， 这些在 Flutter 上都运行得很流畅，轻松上到每秒60帧。
调试效率提高80%，人力节省1/3，而且大态语法相对比较简单，一般1到2周便可以上手开发。团队内部推广 Flutter 阻力非常小。
现在我们已经在一些2级页面使用了 Flutter， 能让我们按照自己的节奏进行迭代，也保证了应用品质。
应用里用 Flutter 做的页面非常稳定，基本消除了崩溃现象。
我们很看好 Flutter， 而且在用了 Flutter for Web 之后，更是决定用 Flutter 来承担我们的大前端战略。
我们现在已经搭建了比较完整的原生加 Flutter 混合工程体系，未来会逐步在更多的独立页面上使用 Flutter， 这个灵活性对我们很重要。
希望能更融入 Flutter 社区吧。我们使用了很多别人写的开源组件，也希望将来能够贡献一些代码回去，让更多的开发者喜欢上 Flutter。
好的产品都是迭代出来的，更好的界面、更流畅的体验，甚至更多样化的使用场景，都离不开高效的迭代，而 Flutter 让这些成为可能。
In today's world, you need to build for many platforms to reach all your users while maintaining quality to keep them happy. Flutter enables you to ship an application for Android, iOS, and the web from a single code base. To do this, Flutter needs a programming language that works on all these platforms and gives you a fast development experience. That's why Flutter chose Dart. Let's take a look at how Dart enables you to develop a Flutter app quickly and deploy it to multiple platforms. If you're developing for mobile, you might be used to slow compile and debug cycles. Dart changes this by enabling one of Flutter's most loved features, Hot Reload, which injects updated Dart source code into your running app and rebuilds your UI in less than a second, so you can see your changes instantly. Also, today's users expect high-quality experiences. Traditionally, you might have used separate teams to build performant apps for each platform. Dart enables you to build high-fidelity Flutter apps for all platforms with one team. Dart's production quality compilers compile to ARM and x64 machine code for mobile or optimized JavaScript for the web, enabling quick app startup times and smooth animations. Finally, Dart is easy to learn. You'll pick up Dart quickly if you're familiar with languages such as Java, Swift, and JavaScript. Together, Dart and Flutter help you create amazing experiences across Android, iOS, and the web. Try Dart in your browser today at dart.dev.
Hi, I'm Martin McGinnis from the Flutter team. In this video, I'm going to discuss what goes on under the hood when you create apps with Flutter and how it's different from other approaches. Nowadays, many apps need to run on multiple platforms like iOS, Android, and the web. That's why Google made Flutter, our UI toolkit to build beautiful native apps from a single codebase without compromising on quality, speed, or performance. Let's take a look at how this is possible. Flutter renders your app itself, rather than letting the platform do so. This means your app is super fast and responsive, and can run on whatever platform you like. There is never any bridge or context switch needed to go between your app and the platform. All that Flutter requires of the platform is a canvas in which to render the widgets so that they can appear on the device screen, and access to events like finger taps and to services like the camera and geolocation. Let's look at how this contrasts with other ways to build for different platforms. One option is to build a separate app for each platform, which often involves a separate team for each codebase. In this system, your code can directly call the built-in platform UI elements, but each codebase will be in a different native language, and your teams will need to ensure consistency between the feature sets in each codebase as the app grows. Another approach to cross-platform development uses only one codebase, but it involves either web views, in which your app creates HTML and displays it in a web view on the platform, as you can see here, or building a bridge from code in a common language like JavaScript to those native UI components like buttons and menus. Whenever you access UI elements, which could be as frequently as 60 times a second with actions like swipe animations and transitions, your app's code has to communicate through a bridge, which may have performance implications. As I mentioned before, Flutter eliminates the bridge and moves your rendering into your app. Internally, Flutter consists of a framework built with Dart and a rendering engine built mostly in C++. Because everything in the top region is Dart, you get a complete stack trace for better debugging, and you can access and change anything in all levels of the framework if you want to. With Flutter, everything you see on the screen is called a widget. A widget can define a structural element like a button or menu, a stylistic element like a font or color scheme, and even an aspect of layout like padding. Let's take a look at some Flutter code. As you can see, the UI is built by composing widgets in the reactive style. Here's what this code produces. By making use of the functional reactive programming style, Flutter can be efficient about determining which parts of your UI have changed. This lets you make changes to your app's data and leave Flutter to efficiently rebuild the app. Flutter also comes with a rich collection of pre-made Material and Cupertino widgets that can be customized so you do not need to make widgets from scratch. That Flutter code you were looking at a second ago is written with a programming language called Dart, which is the secret sauce to a great developer experience. Dart is a special language in that it can be both just-in-time compiled, or JITted, and also ahead-of-time compiled. JITting enables a lightning-fast development experience with a feature called Hot Reload, which allows you to see your code changes in less than a second. When you're ready to release your app to the world, it can be ahead-of-time compiled, which means your app will be fast and responsive for your users. You can get the best of both worlds. So in summary, Flutter allows you to achieve full control over the entire rendering stack, giving you the ability to create beautiful customizable widgets, the advantages of reactive views with no bridge, great developer tools with Hot Reload thanks to the ability to JIT Dart code, fast, smooth, and predictable UI since Dart code can compile ahead of time to native machine code, deployment to multiple platforms with one codebase, and a really fun coding experience. Flutter is free and open source, so visit flutter.dev today to give it a try.
Welcome back to Flutter TV. I'm your favorite host, Dash. I have some exciting news to share. Thanks to you, our channel has over 100,000 subscribers! Whether you're here to discover new widgets on Widget of the Week, or explore a particular topic in depth with Flutter in focus, or see what real-life Flutter development is like minute to minute with the slow burn of the boring show.
Hey, there's a bird loose in the studio.
The Flutter team thanks you from the bottom of their heart for being here, and is thrilled to share the fun of Flutter with you, and
Dash, what did we tell you about using the video camera by yourself?
Not to do it.
That's right.
But Emily is here!
Oh!
But now that you're all here, help me come thank our subscribers!
You're way more than just subscribers. We appreciate that you send in suggestions for Widget of the Week topics.
Or bring up solutions we hadn't considered on The Boring Show.
And support each other by posting replies to comments when people ask for help.
And there's other content on the channel too. You can watch conference talks and events from around the world, check out interviews with the engineering team, and see how people are using Flutter to create apps.
But this is just the beginning. We have so many more ideas for exciting series to bring your way, and we can't wait to share.
Anyone can be a Flutter developer.
Even birds, apparently. We're here to create content that helps you learn. So if you have ideas for different things you'd like to see, share in the comments below. Thank you again for watching, and we can't wait to see what you create next.
Hello, I'm Matt from the Flutter DevRel team. Today we're going to be checking out the wacky world of the Custom Paint widget. What exactly is Custom Paint? Well, Custom Paint is a widget that provides you with a canvas and takes a custom painter to execute paint commands. In this video, we're going to explore the Custom Paint widget and examine how to combine drawing images and shapes on a canvas. The example we'll use is that of a photo with faces that have been identified and highlight them by drawing over the image. To learn more about face detection with Firebase's ML Kit and Flutter, check out the companion video in the description below. Let's take a look at the Custom Paint widget. Typically, it takes a painter and a child in its constructor. The painter is an instance of the Custom Painter class, and this is where the painting magic happens. Let's focus on Custom Painter. This is where canvas drawing takes place. Subclassing from Custom Painter requires two functions to be overridden, paint and should repaint. The paint function is where drawing occurs. It's given both a canvas and a size object. All drawing commands should occur within the bounds of the given size. Circles, lines, rectangles, and many other shapes can all be easily drawn on the canvas with different drawing functions. You can change the properties of how these shapes are painted by customizing the paint object provided to each drawing function. For example, we can update our code to draw an unfilled circle of thickness 10. There are a host of different drawing routines available to the canvas. Check out the docs for a complete list. For something a little more complex and a whole lot more fun, here's a paint function that draws a smiley face using a combination of draw circle and draw arc and a little bit of math. We'll be using this a little later. We also need to implement should repaint, which controls when the painter should redraw. In our example, our custom painter has no mutable properties and so can always return false, as what's drawn never changes. Now, let's take a look at a more complex example, drawing an image to the canvas and painting over it. First, we're going to need to load an image in a format that the canvas can understand. Here, we're loading an image as an array of raw bytes. We can then decode the image using Flutter's decode image from list function and use the result in our custom painter. Let's create a custom painter and pass it our decoded image and coordinates for the faces detected in the image, which are represented here by a list of rects. In our paint function, we can paint the image using canvas.drawImage. Now we can draw an unfilled rectangle around each face, and we should update the should repaint function to repaint if the image or list of faces changes. We reference this from a custom paint widget and we're done, right? Well, not quite. Remember when I said that drawing outside the boundaries of the size given to the paint function is a no-no? When we draw the image on the canvas, the image draws to its full dimensions, which may well be outside the given size. Flutter doesn't actually define what will happen if we do this, but we can assume that this isn't going to be good. So how can we make sure that the canvas is the right size for the image we give it? Luckily for us, there's a widget that lets us explicitly specify its size and the size of its children, sized box. We can wrap our custom paint widget in a sized box that's been given the same size as the image. Our image will now be drawn correctly, but we have a new problem. Our custom paint is wrapped in a widget with a set size, so it won't play nicely with widgets that want to constrain its dimensions in some way. For example, placing our custom paint widget in a container and trying to size it, that's not going to work. We can fix this by using yet another widget, this time a fitted box, which will fit and scale the sized box inside itself while allowing other widget to constrain its dimensions. So we end up with a combination of fitted box, sized box, and custom paint, and our modified image and freshly highlighted faces render elegantly inside our Flutter app. This is a great example of using a simple combination of widgets to achieve some pretty sophisticated behavior, which is a testament to the power and flexibility of Flutter's rendering system. It's easy to work in any canvas drawing you'd like over the image, such as using our smiley face to make sure everyone's super happy in our photos. Hopefully this has given you a taste of painting shapes and images to a canvas in Flutter. For more info, check out flutter.io.
Apps made with Flutter, the open source mobile SDK from Google, are composed of widgets. Each one is a lightweight object designed to do a specific task, like keep content away from notches, or animate transitions, or even fit one widget inside another. Becoming familiar with all the widgets provided by the SDK is an important step toward becoming an experienced Flutter developer. So to help, we created Widget of the Week. It's a weekly series of short, animated videos, each showing the important features of one particular widget. In about 60 seconds, you'll see real code for each one and a demo of how it works. Plus, learn the best times to use that widget and get a heads up on its most important properties. It's a quick way to get to know some of the most important Flutter widgets, and you can find all the videos here on the Flutter YouTube channel.
Many apps are built around dynamic lists. Items are added, removed, and changed all the time. Without animation, this can be jarring and confusing. Why did everything jump? What just happened? Animated List provides an easy way to animate lists. Start by providing an item builder. This is a function that will be called for every index of the list, so you can construct each item. You also get an animation which automatically starts when the item is added and which you can use to animate the item in. Your animation can be anything. Unless your list starts empty, you will also want to provide the initial item count. Now you need to tell Animated List whenever there is anything added or removed from the underlying data structure. To do this, you call methods on the Animated List state. This class has the methods insertItem and removedItem. How to get hold of Animated List state though? There are two methods. When you want to initiate an animation from inside the list code, from inside one of the items, you can use animatedList.off_context. From anywhere else, use a global key. Attach it to the Animated List widget, and now you can call insertItem, removeItem from anywhere. Let's have a look at those methods. With insertItem, you tell Animated List that there is a new item at index and that it should start the animation. To construct the newly added item, Animated List uses the item builder, which you already defined. It is important that you not only call the Animated List state method, but also actually update your underlying data. RemoveItem is similar. You tell Animated List that the item at index is being removed. You also need to provide a builder for the widget to show while it's animating out. Once again, you are provided with an animation that you can use, and the sky is the limit for what that animation looks like. And remember, it's important to remove the item from the underlying data structure. For more info on Animated List and all the other widgets, head to flutter.dev.
Hello, I'm Martin McGinnis. Welcome to our series on animation building blocks in Flutter. In this series, we're going to introduce you to animations in Flutter and show you how to build both simple and complex animations for your Flutter app. In this first video, we're going to focus on the most straightforward way to add animations to your app. You don't have to be an expert on animations or animation terminology to add animations to your app. Along the way, we'll introduce some widgets and terminology that will help you get started with animations right away, as well as give you some background for the rest of the episodes. Flutter includes a series of widgets that are animated versions of existing widgets that you've probably already used in your app, such as the animated container version of the container widget and the animated position version of the positioned widget. These widgets automatically animate changes to their properties. When you rebuild the widget with new property values, such as with stateful widget's set state, the widget will handle driving the animation from the previous value to the new value. These widgets are called implicitly animated widgets, and these widgets will typically be the first thing you reach for when you need to add animations to your app. They provide a means of adding animations without adding additional complexity. Let's look a little closer at how you can use one of these implicitly animated widgets to add some animations to your app. In this app, we have a container and a button. When the button is pressed, set state is called and the container is rebuilt with a new value for width. You'll notice that the container changes its width immediately without any animation. We can add some animation to this app by swapping the container widget with an animated container widget and specifying an animation duration. Now, when the button is pressed, the container will gradually animate from the previous width value to the new value. The process of animating through the values between the old and the new is called interpolation. The animated container handles interpolating its property between old and new values whenever they change. This applies to all the animated container's properties, including, for example, the decoration. We can modify the gradient with a decoration, and the animated container will handle interpolating between the old and new gradient. Implicitly animated widgets like animated container have two properties that you can use to control the animation's behavior. You can control how long it takes to interpolate to the new value by setting the duration property. In this example, we made the animation take